So hello and welcome to new DevOps project. So in this video we'll be deploying a web porting application using Kubernetes. So this is a cloud native web application and is built using a mix of technologies. So it is designed in a way so that it will be accessible to the user via internet, and using which the user can port for their preferred programming language. So there are multiple languages options. So the language includes C#, Python, JavaScript, Go, Java and Node.js, and we can cast our board accordingly. So talking about the technical stack, as we can see, it's a 3-tier application and it's segregated into the front-end, API and Mongo. So talking about the front-end of this application is built using React and JavaScript, and it provides a responsive and user-friendly interface for casting the boards. Then we'll be having backend. So the backend of this application is powered by Golang. So it serves as the API handling for the user board request. And for the database, we'll be using MongoDB. So in this architecture itself, we can see the MongoDB is used as a database backend, and it is also configured with the replicaset for data redundancy and high availability as well. And so as I mentioned, we'll be using AWS EKS managed service for this deployment. So this will be a production grade deployment. I hope this video will add on your Kubernetes understanding and the process of deployment itself. So for this we'll be using multiple Kubernetes resources. So the resources that we'll be using will include namespace. So as you can see, ns equals to Nepal tech-tube is set as the namespace on the figure itself. So Kubernetes namespace are utilized to create isolated environment for different components of the application, ensuring separation and organization itself. Then we'll be using secret. So Kubernetes secrets store sensitive information such as API keys or credentials required by the application in order to access in a secure manner. Then we'll be using deployment. So Kubernetes deployment define how many parts of the application should run and provide instruction for updating and scaling as well. Then we'll be using service. As you can see, we are using 3 services. So the front-end, API and Mongo service. So for the 2 front-end and API, we'll be using load balancer as the service, and for Mongo we'll be using cluster IP itself, since Mongo is required to be accessible on the internal network. So we will not expose it outside the application or the cluster. Then will be using the stateful set. So for components like database, which requires statefulness, such as MongoDB, so MongoDB replica is used, and Kubernetes stateful sets are employed to maintain the order and maintain its identities as well. Then we'll be using persistent volume and persistent volume claim, as we can see on figure. So these Kubernetes resources used to help and manage the storage required for the application, and also ensures data persistency and scalability as well. And talking about the learning opportunities in this video or in this demo series, so the first one we'll be understanding is containerization. We'll gain hands-on experience with containerization technologies like Docker for packaging application and their dependencies. And we'll also be learning about container orchestration tool like Kubernetes. So we'll learn how to leverage Kubernetes to efficiently manage, deploy and scale containerized application in a production environment. Then we'll also be taking a look on microservices architecture. We'll explore the benefits and challenges of a microservice architecture where the front end and back end are decoupled and are independently scalable as well. Then we'll also be taking a look on database replication. We'll understand how to set up and manage a MongoDB replica set for data redundancy and high availability. Then we'll also be taking a look, or we'll have an understanding regarding security and secrets management. We'll learn the best practices for securing sensitive information using Kubernetes secrets. Then we'll also be understanding stateful application. So we'll also gain insights into the nuances of deploying stateful application within a container orchestration environment. And the last one, we'll also understand what persistent storage is. So we'll understand how Kubernetes manages and provisions persistent storage for the application with state. So yes, by working through this project, we'll develop a deeper understanding of cloud native application development, containerization, Kubernetes, and the other various technologies involved in building and deploying modern web application. So in order to interact with the cluster, we'll be using kubectl. So it's a utility, and as we can see, we can browse the application through the Explorer or the web browser using any of the web browser. So the get/path request will be carried out or will be handled by the front-end service, and other kinds of AJAX related queries will be handled by the API. So talking about AJAX, it's a asynchronous JavaScript and XML, and it is used for creating fast and dynamic pages, and it can also be used to bring personalized data items dynamically. So we'll be using AJAX. So without further ado, let's move on to our AWS console and let's get started with the application. Okay, so as we can see, I am at the AWS login console, and currently I am selected the Ohio region for the application deployment. So let's get started. Let us first create a EKS cluster. So for that, we'll go to EKS Service, that is Elastic Kubernetes Service, and here we can see there is a add cluster option. So I'll create a cluster here. So first let me put the cluster name. So that will be EKS cluster. So the version of this cluster, Kubernetes cluster is set to 1.28. I think this is the default one as well. And so talking about the cluster service role, so currently I am selecting this role, my AWS EKS cluster role. Okay, so let me show you the role as well. What are the roles that are predefined here? Okay, so as you can see, I am logged in here. So as I mentioned, I'll be using the role my AWS EKS cluster role, and we can see the policies here. So the policies that I've set for this is Amazon EKS cluster policy. So let's go back to the cluster section itself. So this is the current role that I've selected. So I'll be moving on to the next. So I have selected the default VPC and the default subnet that are being provided by this VPC. And let me choose the security group. So I'll be choosing the default security group that is provided, and choose the cluster IP family address. So I'll be selecting the IPv4 itself here, and the cluster endpoint access is set to public so that this cluster will be available or the accessible from outside of the VPC. So configure logging. So in order to monitor the EKS cluster, we need to enable the logging, but currently this is for the demo, so I'll not be configuring the logging here. So let me move on with the next. So as we can see, there are multiple add-ons or EKS add-ons that is provided by AWS. So by default, these are the EKS add-ons that are provided. So Core DNS, so it helps in service discovery within the cluster. So it lies under the networking category. And we have kubeproxy, so it also enables service networking within the cluster. And we have Amazon VPC, Virtual Private Cloud, CNI. So it also enables pod networking within our cluster. So by default, these are the add-ons that we need to add to our cluster. So the version is set for Core DNS to 1.10.1. Then we have kubeproxy, whose version is 1.28.1. And we have VPC CNI, whose version is 1.14.1. So let's move on with the next. Okay, so these are the configured settings that we have selected. So I won't be changing any other things. So let's create. So this creating a cluster might take around 15 to 20 minutes. So as we can see, the status is creating. So let's wait for some time. So before that, let's add one add-on here. So the other one add-on that we'll be adding is Amazon EBS CSI, since we are using MongoDB and we need to persist our data. So for that, we'll be using EBS CSI driver. Okay, let me add this one and let me move to next. So the version of EBS CSI driver is set to 1.23.0. And the select IAM role, so it's been selected as inherit from node. So we do not need to provide any other. It will be inheriting the IAM role from the node itself. Okay, let me select next and let me create this as well. So this will be adding the EBS CSI on our cluster as an add-on. And let's move to the ECS section, as in order to interact with the cluster we'll be requiring an instance. So for that we can use the local instance as well, but in order to make it more transparent to anyone following this one, so if you use any of the instances that is provided by AWS, you could easily set up this project on your own or on your end as well. So let me go to instances and let me launch an instance. So as we can see, I have set the instance name to prod server. Okay, so I'll be using the image Amazon Linux 2023 AMI, and the architecture is set to 64-bit x86, and I'll be selecting the T2 micro instance type, which also falls under the free tier eligible as well. And for the key pair login, I'll be selecting prod server key. And also one thing, so we'll be connecting to the instance within the AWS console itself, so we do not need this key pair, but during the creation period we do need to provide this, so I'm providing this. And as we can see, the network, it's using this VPC, and the subnet will be automatically selected, and it will be creating a security group and will be allowing SSH traffic, that is port 22 will be opened and the traffic will be enabled through this port only. And the storage is set to 8 GB and the type is set to ZP3. Okay, so I'll be launching the instance. So we are almost done with this process as well. Okay, let me go and check if the instance is on the running state. So still it's on the pending state, so it might take some time. So let's see if the cluster is, so it's still creating. So as I mentioned, it will be taking almost 10 to 15 or 20 minutes itself. So let's go here and let me check the instance. First we'll be requiring kubectl to be installed on the instance. So let me connect to the instance. Okay, so I'm connected with the instance now. Okay, so let's follow the steps. So as we can see, I have written the manifest file for this application. So let me go to the readme.md. Here we can see the installation steps that we require for this. So first of all, we'll be installing the kubectl. So for that, I'll be running this command for the installation purpose. So this will be downloading the kubectl. So if I do kubectl version, so we can see the version of kubectl is set to 4.5.4. So let me clear this. And we'll also be requiring AWS CLI to be installed here. This will be installing the kubectl. So it's inflating and will be creating accordingly. So this might take some time. So since AWS CLI is almost compatible with all the services, so all the services and their packages will be installed and will be inflated. So this might take some time. So these are the manifest file that we'll be writing. So there will be, so let's start with the front end. So there will be a deployment for the front end. So the API version is set to app version 1. The kind is deployment. So the metadata is, so as we can see, all the information will be provided here. So this will be a core technical demo instead of the theoretical demo. So I think this will be accessible on my GitHub as well, so you can check it from there. So I'll not be describing each and every component here. So the namespace is set to Nepal tech. So the label for this deployment is set to frontend, and the environment it's using is set to demo. So the specification, we can see the replica is 2. So it will be creating 2 pods, and the strategy is rolling update type. And rolling update, we can see max surge is set to 1 and max unavailable is set to 25%. And it will be matching the selector label that is set to frontend, and the template that we are using is set to frontend. And we can see the specification. So the container name is set to frontend, and the image that we are using for the frontend is Cloud Academy DevOps / frontend version 11, and the image pull policy is set to always, and the environment we could see. So the React API host will be using this value for interacting with the API. So this API, after creating the API deployment and the service, so service will be providing us with the DNS name, and this will be parsed through this API value, and the container port is set to 8080, and the liveliness probe is set to path -OK, and the port is 8080, and initial delay seconds will be set to 10 seconds, and the period second will be set to 5 seconds, and the readiness probe, as we can see, the path is also set to /OK, and the other things are set here. So I won't be going through each and every, so you can do Google search on it itself. So then we have API deployment. So the same for this, namespace is set to Nepal tech, replica will be 2 replicas, so it will be creating 2 pods for the API deployment as well, and we'll be having the type set to rolling update. So as we can see, rolling update is set to type. We can also set it as recreate as well, but we'll be selecting rolling update. And the image, as we can see, is set to Cloud Academy DevOps / API version 3. And so talking about this API needs to interact with the database. So we need to provide the database environment files that are Mongo connection string, Mongo username, and Mongo password. And for passing the username, we'll be creating secret file, and where we'll be storing the username and password, and they are referenced in this manner. And the other thing we can see, so the liveliness probe, readiness probe are set according to the front-end deployment itself. Then we have Mongo stateful set. So for this, the kind is set to stateful set. The metadata for this deployment is known as Mongo, and the namespace is Nepal tech itself, and the service name will be defining it as Mongo. And so in the previous front-end and API deployment, we could see the replica were set to 2, but we'll be having 3 replicas, as I showed on the architecture on the first half itself. So for this, it will be using Mongo image, and the container name is set to Mongo. So these are the sets of command that this container will be running on the start. And so this is a database, so we need to mount path. So path within the container at which the volumes will be mounted, and we'll also provide the mount propagation. So here we can see the mount part is set to /data/db, and this is the persistent volume claim templates itself. So the volume claim template is set to Mongo persistent storage claim, and the storage class is GP2, and the storage size is set to 0.5 gigabits. And let me show you the service for Mongo. So the service for Mongo is set to cluster IP is set to none, so we do not need to interact the MongoDB from outside of the VPC or outside of the cluster, so we are not using the service type accordingly. So we are using cluster IP, and the port is set to 27017, and the target port is also set to 27017, and the namespace we are using is Nepal tech. So this is the Mongo service, and the Mongo secret, as we can see, we are using username and password, and I'll be showing you what we are using this during the deployment itself. So let's go back. I think it's done. So the AWS CLI is set. So let me clear this and let me configure once, so that it will be interacting with our AWS account. So for this, I have the secrets, that is API key, the access key and the secret key that are provided by AWS. So this is the access key, and let me also paste the secret key here. So I'll be selecting the default region to US is 2. So let me clear this. And okay, so we are almost done with the AWS configuration. So let me check kubectl get nodes if it shows any. So as we can see, the connection to the server localhost 80 was reviewed. Did we specify the right host port? So for this, let me do one thing. So let me list the AWS EKS cluster. So AWS EKS list. Okay, so I can see CLUSTER. So this is the cluster name. Okay, so looks like the C is capital, so we were having issue. Okay, so we are done with this. So if I do kubectl get nodes, so as we can see, there are no resources currently found. So in order to provide resources, we need to first create the resources itself. So first and foremost, let's set up the Git for this. So currently I have not pushed this to my GitHub. So let me go ahead and let me open terminal first. Also let me add a git ignore file here. Git iz and git ignore. Okay, it's okay. So let me initialize the git here. Let me go to my GitHub and create a repo. Okay, so I am successfully logged into my GitHub. So let me create an new repository here. So it will be my AWS EKS RZM. So R refers to React, Z for Golang, and M for MongoDB. AWS EKS RZM. So let me create a repository here. And also one thing, so inside git ignore I want to add my secrets.txt file so that my secrets will be maintained. Okay, so commit is main. So let me switch to the branch main. Okay, so let me add the remote origin. And let me push this to my origin main. So the push has been made. So let's refresh this. So what we did was we write our manifest file on our local machine and we pushed it to Git repository. Now we'll be cloning this on our EC2 instance. So let me go ahead and check if Git is installed or not. So Git command not found. So we need to first install Git. So the Git is installed. So yes. Then I'll be cloning my repo. So let me copy my repo URL. Okay, so I have successfully cloned my repo URL. So if I do ls, I can see my AWS EKS RZM. So let me cd to my AWS EKS RZM. Let me do ls here and let me go again inside the manifest file. Let me do ls. So these are the things that we'll be requiring. Okay, so let me first create a namespace. Okay, so kubectl create namespace and my namespace will be Nepal Tech. So the namespace is created and I'll also be setting this namespace as my default namespace so that I do not need to provide the namespace flag every time whenever I am trying to search for the resources. So ctl config set context, and my current namespace will be Nepal tech. Okay, so the context is modified now. So Nepal tech is set as the default namespace. Okay, so we are good to go now. Now we'll be doing the Mongo database setup. So to create Mongo stateful set with persistent volume, we need to run the Mongo stateful set.yaml. So let me once check what's inside here. So as I showed this on the Visual Code stream, so these are the same thing that we have done. So the namespace it will be using Nepal tech, and the image it will be using is Mongo image. So other it will remain cluster is okay. So first let's create our node group here. So for that, let me go to compute section and we'll be creating a node group. Okay, so my node group will be node group itself, and select the role. So for this I'll be selecting a role. So for this we can see I have my Amazon EKS node role. So let me show you what are the policies that are provided here for this node group. Let me go to role and let me select the node group role. So this is the node group role, and here we can see this is the policy that we have added. So AWS service role for Amazon EKS node group. So this is what we are using. Okay, so this is the role that I have selected, and everything I'll be setting it as it is. We have added the name and provided the IAM as well, and the image type will be Amazon Linux, and the capacity will be in demand. And so for this I'll be selecting T2 medium. So that will be 4 vSphere, 4 GB RAM, and the disk size is set to 20 GB, and the desired size is set to 2 nodes, and the minimum and maximum is also set to 2 nodes. And as we can see, node group update configuration, so we'll be setting it to number and value will be set to 1 node. So for subnet we are selecting the default subnet that is provided by the default VPC. So let's move on to next and let us review this. So I think we are good to go. So let's create the node group, which will be creating 2 nodes within the node group. Okay, so this might take some time. Okay, so finally we could see our nodes are placed, and we can see 2 nodes are ready. So the age for the nodes we can see they are created 13 minutes ago. Okay, so our cluster is ready, our roles for the cluster and nodes are also ready. So now we can move on with the deployment. So let us first start with the MongoDB deployment. So for MongoDB, let me go to my root directory and let me go to my AWS EKS RGM, and inside that we have manifest file there. So let me do ls, and we could see there is a Mongo stateful set.yml. So before creating this, we need to have a namespace in place, because as we know, within the Mongo stateful set there is a namespace set to this. So we need to match the namespace. So for that we created a namespace. So kubectl get ns will be giving us the namespaces. So here we can see Nepal Tech is one of the namespace that we have created. So let's get started with the deployment. So kubectl apply -f and mongo stateful set.yml. Okay, so the stateful set is created. So if I do kubectl get out, we can see a pod that's getting created, and we can see the stateful set 0 out of 3 ready. So let's wait for some time so that this will be created. And before that we also need to, and after that we need to create the service for this MongoDB, and also we need to create secrets for this one. So after creating this stateful set, if I show you here within my EC2 section, so within the instance section we could see this is the prod server that we are trying to connect for kubectl. So let me add this a name node1, and the other one will be node2. And within the storage, let's check. So as I mentioned, while creating the node, the volume size was selected as 20, but here we can see there is a disk where we have the volume 20 GB there, and we also have this one. So after creating the stateful set, this volume is created and added here, and the same goes for node 1 as well. If we see on the node section, so it's attached here. So yes, we are good to go now. Okay, so we have applied the Mongo stateful.yml. Now let's move on and let's create the service for this one. First let me do this, and let's see what are the things that are created. So here we can see 3 pods are created for Mongo 0, Mongo 1 and Mongo 2, and we also have the stateful set here. So let me clear this and let's deploy the Mongo service. So okay, so this will be creating the Mongo service. So now if I do kubectl get all, so we can see the the service Mongo with the type cluster IP is also created. And let me check the persistent volume as well. So get pb. So here we can see 3 persistent volume are created, 1 and 1 GB. So particularly this will be this one. So 2 of the persistent volume are attached to one node, and the other out of 3 other one is attached to this one. So we are good to go. So we are trying to create a MongoDB pod where we are creating 3 pods for this, and so the first pod will be acting as a primary database and the other will be secondary. So the read and write will be supported by the Mongo 0 and will be working accordingly. So for that, let me go to kubectl exec and -it and Mongo 0, and we'll be entering into the Mongo cell. So here we'll be creating a DB with name langdb. So this is for the language DB. And let me go here and let me copy the code from my file. So on Mongo 0 pod, initialize the Mongo database replicaset. In the terminal, we need to run this command so that it will be setting the primary and setting secondary accordingly. Okay, so this takes some time to implement this. Okay, it's done. So let me do this, or let me run this command. Okay, let me do direct itself. So rs.status. Okay, no issues. So let me show from here itself. So the Mongo 0 is set to the primary. So this is the Mongo 0. Then we have Mongo 1, so it is set to secondary, and we also have Mongo 2, which is also set to secondary. So in this way we have the three pods, where the first is acting as a primary and the other are acting as the secondary. So for the commands that I ran earlier, you can check this from the Google itself. So we'll be adding some data inside the database. So for that, okay, let me go to my code section, and so this will be adding the data within my database. Okay, so they are getting started. Okay, let's check if they are getting added or not. So for that we have db.languages languages dot find. So looks like the data is added. So let me take a look in pretty format. So here we can see we have 6 languages. So the first one is C#, whose words count we could see is set to 0. We have Python, whose words count is set to 0. We have JavaScript, we have Go, we have Java, and we have Node.js. So let me clear this. Okay, let me exit out of this MongoDB. So we are good to go. We have created a Mongo database. We have added the architecture so as there will be one primary and the other will be working as secondary. So now let's do one thing. So let's do the API deployment. So let me clear this once and let's do ls. So here we can see there is a API deployment file. So let me cat to API deployment, and here we can see one thing that I need to show you is so the values for the username and password is set here, and the username and values are being generated from the or referenced from the Mongo secret. So for that we need to first apply the Mongo secret file first. So for that kubectl apply -m mongo secret.yml. So the secret is added. So let me show you the Mongo secret as well. So here we can see the username and password is set to this. So if I copy this, so this is base 64 encoded. So let me go here and base 64 decoder. So if I go here and if I paste this here, let me decode this. We can see the admin is base 64 encoded, and we'll getting this value. The same goes for the password as well. So let me copy the password. Okay, so let me paste this here. So this is the password. So I hope a clear understanding regarding the secret management using Kubernetes secret is being understand here. So let me clear this and let's move on with the API deployment. So before that, let's check what are the things that we did till now. So we created pod and so on. So talking about Mongo database part, we have successfully created that. Now so here we can see in a wide format. So the node are this one. So the IP associated are this one, and we will see all 3 pods are running, and we have the Mongo service and stateful set as well. So kubectl. So we can also see MongoDB secret as well, and kubectl get pv, and the persistent volume claim are shown here, and so we are good to go now. Okay, so let's deploy the application. So kubectl apply -f API deployment.yml. So this will be deploying the API. So we are good to go with the API as well. Now the one thing that we need to do is let's just check. So there we can see 2 pods are added for the API. So we are good to go. So as I mentioned earlier, we are also deployment slash API, and we also have replicaset slash API. So within the deployment file, we mentioned that our replicas need to be of 2. So the replica set is set to 2, and we have 2 pods which are on running state. So API part is done. So as I showed you on the figure, so our API is being accessed with the load balancer. So we need to create a service for that. So we'll be creating a load balancer service. So let's go here and let me clear this. And let us create a service for, so kubectl. We can also write manifest file for the API service as well, but I'll be creating this. And before creating this, let me show you one thing within the load balancer section. So there is no load balancer here. So after creating this service, or after exposing the API service, the load balancer will be created here. Okay, so kubectl expose deployment and API hyphen name. So the name will be API. So since we are creating the service for API, and the type will be load balancer, and also we'll be setting the port to 80, and our target port will be target hyphen port will be 8080. Okay, so service API export. So let me go to the load balancer section and let's refresh once. So here we can see a load balancer is created. So this load balancer, as according to the figure, this is the load balancer that's being created. So this is the service. So now within the internet we can access this API. So let us go back to my EC2 instance section. Let me clear this. Now let's see the steps here. So Mongo secret is applied. So API setup is done. We also did the deployment through service. And now we need to set the service endpoint over the environment variable. So for that, let me run this command. Okay, so the DNS propagation is taking action. So this might take some time. So let's wait for some time so that this will be propagated and we can access this from the URL itself. So let me do one thing, kubectl get all, or let me check the services only. Okay, so these are the services. Let me copy this external IP once and let me paste it here. So I'll be closing this. We don't need this, and we'll also be closing this. So let me go here and let me paste this. Okay, so the default page is not set here. So as I said, we'll be using /OK to verify. So it must return OK. So here we can see it's returning with OK. And also we have added the data there. We added the 6 languages. So let me also check that. Okay, so the languages are also getting shown here. So C#, we had other as well. So Python, we have C#, then we have Python, we have C#, we have JavaScript, we have Java as well. So in this way 6 languages are already added here. So data is getting replicated. So we are done with the API part as well. Now we'll be moving on with the front end. So as of now, as we have seen, we created a stateful set deployment using which 3 pods for MongoDB were created, and we also created the persistent volume and persistent volume claim as well for this. And we created a service for MongoDB. We created a cluster IP service. Then we did the API deployment. Then using the deployment, we are having 2 replicas by the help of replicaset. Then we created a service and for API, and the service was set to load balancer type, based on which we are able to access the website from our external endpoint as well. or from the web browser itself. So we are good to go now. Now we need to be setting up the front end. So for that, let me show you the steps. Okay, I'm back to this and let me clear this. So the API and the database interaction is successful. Now we are working on the front end. So let me go to the documentation here and test and confirm the API route. So we already confirmed. So let me once again do this crawl request. Okay, so Go, Java, JavaScript, Node.js, everything is getting shown here. So if we want to check it specifically, we can also check here. So slash languages. This will be slash Python. So here we can see the individual or personalized data items can be generated. So I generated for the Python. So here we can see the vote is set to 0. So we'll be setting up the front end and we'll be voting from there and we'll be checking the changes if they are getting applied or not. So let me clear this and let's go here. So now we are done with database and the API part. So let's apply the front end deployment. So kubectl apply -app front end deployment.yml. So the deployment is also created. kubectl get. So after creating this deployment, we can see two pods for front end are created and we have two deployment types, that is for API and front end, and as we have set replica set for the front end pods as well. So here we can see replica set.apps for the front end as well. So let me clear this. So let me once show you from the manifest file itself. So not for the API, for the front end. So here we can see the replica is set to 2, so 2 pods are created. And also one thing, so our API or the front end needs to interact with the API. So for that we have this value placed here. So this will be taking the DNS name of the API and will be interacting accordingly. So let me clear this and let's do one thing here. So let's create the service for that. So kubectl expose deployment, front end will be my deployment name and my name is front end and the type is set to load balancer and the port is set to 80 and the target port will also be setting to 80. Sorry, 8080. Okay, so there's a typo here. I hope we are good to go. So after this deployment, so there is only a single load balancer here. So if I refresh, there will be another load balancer added. So the first one that we had created was for API and this one is for the front end. It is same to the architecture that we are following. So the API has a load balancer and the front end also has a load balancer. So now we are good to go. So let's follow the documentation here. Okay, so the confirm the front end ELB is ready to receive traffic. So let me copy this and let me paste this. So we'll have understanding that DNS is propagated or not. Okay, so DNS propagation might take some time. Let's wait for some time. Okay, so it looks like the DNS propagation is successful. So let me copy this command. So it will be echoing the DNS name for us. So let me paste this. So this is the URL. So using this URL, we can check our front end and add values as well. Okay, so language port, the apps is shown here. Okay, so looks like the API interaction from the front end is not getting done. So here we can see error name not resolved. So based on which we are getting this alert or this issue over the console. So for that, let me do one thing. Let's come back to our EC2 instance connection and kubectl delete. So I'll be deleting the deployment here. And I'll be showing you what caused this issue and how we can fix this. So I'll be removing the service for the front end and I'll be removing the deployment for the front end itself. So both the deployment for the front end and the service for the front end that we created is deleted. So deleting service might take some time because it do have to delete the load balancer here as well. So now if I refresh, we'll be seeing only one load balancer here. Okay, so looks like the service is also deleted. So let me clear this and let me show you what was the issue that caused this problem. So here we can see failed to load resource. So error name not resolved. So API ELB public FQDN. So this was not working. So for this, what we need to do is okay, no issue. So let me copy this. And let me echo here. So since the DNS name can't be resolved, so we'll be pasting this over the front-end deployment file. So let me go there. And let me add the API ELB public FQDN. Looks like it's yet to copy it, so I don't want to save this. Why isn't this copied? So let me copy this once again and let me try to paste here so that we'll have a clear understanding. So yes, it's copied. So let me again change the front-end deployment. Okay, so we are good to go now. So let's apply the deployment file for the front end. Also create the service for this. So I'll be using the same command that we had used earlier for creating the service for front end. So this is the one. So the service is also exposed. Now let me run the command for this. So this will be providing the DNS propagation details. Okay, so looks like the DNS propagation is successful. So let me echo the, not the API ELv1, so let me echo the frontend ELv1. So let's copy this. Let me go to. So finally we could see the interaction between the front end and the API is getting done. So we are getting the values here. So let me add both for C#, also for Python, also for JavaScript, for Node.js as well, Java, and I'll be adding bots for Golang as well. So here we can see the C# bots is set to 10, Python is set to 3, JavaScript is set to, let me set it to 4, and Node.js is also set to 4, so let me set it to 5. So this is the things that we are adding through the front end. So the main thing that we were trying to do for this project was that using front end, we were trying to provide a responsive and user-friendly interface for casting bot, which is successful. And also regarding the backend and API, as I said, so the API handling will be done with the help of Go API, where we'll be, or the user will be adding the bots, and MongoDB is storing the database at the backend. So let us go to the MongoDB and check if this is getting reflected on the database or not. So for this I have this command. So let me execute this command on this. So here we can see. So this is for the C#. So for C# we can see the bots is set to 10. Okay, so this is the one. So as we can see, so bots for C# is set to 10. So the bots for Python is set to 3. So let me make this 7, 5, 6, 7. Okay. So the database, if we see, it will be showing us 3 because after this only the bots were added for Python. So here we can see the bots set to 3. If I read on this command or the query, we could see the bots for Python is set to 7. So in this way we can deploy our cloud native application using AWS EKS. So if you have any question, you could please feel free to share over the comment section. I'll be reaching out to you.